Hi everybody, this is Mrs. Lindsay. If you have not watched that first video on limit definition / difference quotient, please take a moment. You don't need to take notes on it. It's a real quick video. It's only a few minutes, so watch that and then come back and play this one. Okay, so using the difference quotient, as we take the limit as h approaches 0, this is your limit definition of a derivative. So whenever it asks you to find the derivative of a function, you're going to apply the limit as h goes to 0 of the difference function. Okay, so let's go ahead and try a few examples of these. I'm going to jump down to number 2 here. So I'm going to find the limit as h approaches 0 of the difference quotient. Okay. So the limit as h approaches 0, I'm going to find f of x plus h, so we'll substitute that in. So x plus h quantity squared minus the original function all over h. Now we're going to use a lot of our algebra toolbox, different ideas, things that we know that we've done throughout the entire year to simplify this. So we're going to actually FOIL or multiply that out. So you'd get 3 times x squared plus 2xh plus h squared minus 3, sorry, this is writing very awkwardly here for some reason, all over h. Okay. Now if I distribute in that 3, hopefully you'll see that things will start canceling. Okay, so we're going to bring this through. So I'll have 3x squared plus 6xh plus 3h squared minus 3x squared all over h. And hopefully you'll see here that these will cancel, the 3x squareds, and then you can pull a h out. So I know this is taking a few steps, and I'm actually going to start writing in here to part 3 or number 3. But hopefully as you get better at this and you have been practicing, that you can start skipping a few steps or do a little side work. Maybe just do all that foiling on the side. Okay, so now I'm going to pull out that h, get 6x plus 3h, and then you can see the h cancels. Okay, so now we simply are at the point, again, where we substitute in 0 for h, and that will cancel out your 3h term. So your derivative is 6x. So your derivative of your function f would be 6x. So what does this tell us? I can find the slope at anywhere along the original graph of 3x squared. So if I know the x value, I can plug that in. I'll find my y coordinate, which gives me the slope at that point. So I can find the slope at 2. I can find the slope at x equals 20. I can find the slope anywhere along that graph using your derivative. Okay. All right, so I'm going to flip the page. I'm going to go down to number 6. So exact same thing. We're going to apply the limit definition. I'm not going to actually write the definition this first time. I'm just simply going to substitute in x plus h. So I'd have 4 times the quantity x plus h squared plus the quantity x plus h minus 2 all over h. And I forgot one part. It's easy to do. I have to subtract the original function. Okay, so I'd like you to pause the video. I want you to just simply simplify the numerator right now. FOIL, distribute, bring through the negative, simplify that numerator, and push play when you're ready to check that. All right, so I simplified it. And then you can see that things start canceling. Again, all I did was multiply through the top, distribute through the negatives, etc. So you can see a lot of things start canceling. Our x cancels, our 2, our 4x squared. So again, I am going to take out an h here. So I get 8x plus 4h plus 1, if I factor out an h there. Then this h will cancel. Again, so now I'm at that point where I can substitute in h equals 0. We just want to keep simplifying until we get to a point where we can't. If I plug in this, that becomes 0. So my limit as h approaches 0, so in other words, my derivative is going to be 8x plus 1. Okay, and we're going to keep applying the same technique. We're just going to apply it to different types of functions that we've done throughout the year. Okay, so now we're going to move on here to 7. Okay, so with 7, you can see that our function has changed. It's now a square root. Doesn't change what we do. We're still going to use the differential quotient and find the limit as it approaches 0. So in this case, we'll have underneath the square root 3 times the quantity x plus h plus 4. Now I have to subtract the original function all over h. Okay, now hopefully this looks familiar to you. There is nothing we can do here. Yes, I know I can distribute through this 3, but that doesn't mean I can now simplify in any way, shape, or form. So we're going to do multiplying by the conjugate. So I'm going to multiply by the numerator, except I'm going to change the sign in the middle and put it as an addition. And we're going to multiply the top and bottom by the exact same thing, multiplying by the conjugate. And again, hopefully you're at that point where you can kind of skip some steps. I'm going to write a few extra steps that I wouldn't always do, but if you need to write them down, please write them down, okay? So when you distribute here, what's the point of multiplying by the conjugate, right? The middle two terms cancel each other out. So when I distribute in this first case here, the limit, again, as h approaches 0, we haven't even addressed that yet. When I multiply there, that's the same thing, so it just cancels each square root out. When I take this term times the middle term, those will cancel each other out because I'll have the same term, one positive, one negative. So all I have to then worry about is multiplying the last two terms. And again, the exact same thing will happen. But please notice it does cancel the square root. But again, I have to keep that in parentheses because this negative needs to distribute. And again, it's all over h times my conjugate. Notice I did not multiply through the h, and you're going to see why. Saves you guys a little bit of time not to multiply that h through. Okay, so there was a lot going on there. Okay, just like before, simplify. So if you simplify here, I'll go ahead and distribute through. And again, I'm taking some extra space with these. But hopefully you see already that the 3x's and the 4's are going to cancel. And I'm not even going to, I'm just going to write it like this, because I know that's what it is. But 3x's cancel, the 4's cancel, and then hopefully you even see this h is going to cancel there. So now I'm going to have the limit as h approaches 0, it's going to be just simply 3 in the numerator and then my conjugate in the denominator. So again, a lot of just simplifying algebra. So here's the step that I did skip. In the numerator, when everything cancels out, I have a 3h, and then I have, again, my conjugate in the denominator h, and this is what cancels. So 3 just remains in the numerator. Now I'm at the point where I can substitute in 0 for h, so again, that's going to disappear. So I'll get this to be 3 over the square root of 3x plus 4 plus another 3x plus 4, which gives me 3 over 2 of those, because those are like terms. So I can add those together. So that is your derivative. So a little bit more algebra intense with this because you have to multiply by that conjugate. And you're going to see the next problem that we do too is also going to be a little bit heavy in terms of algebra and simplifying. But again, this is what we've been doing through this year in terms of our functions. Okay. All right. So the next one that I'm going to do, I'm going to skip all the way over to 12, the very last problem. Now we have 2 over the quantity 3x minus 1 for our function. Again, we're still going to apply the difference quotient as the limit of h approaches 0. So I substitute in initially x plus h. Then I subtract the original function over h. So again, hopefully this looks a little bit familiar. Yes, I can distribute through the 3 here, but I'm not going to be able to do the subtraction. There's 2 different ways to do it. You can multiply by, again, what I call the baby LCD. Or you can actually combine like terms, get like denominators, and do the subtraction, and then change it to division. I'm going to multiply top and bottom by the baby LCD. So this denominator 3x minus 1, and also this denominator 3x plus 3h minus 1. So when I first multiply here, the 3x minus 1 will cancel. Okay, so the limit as h approaches 0. So again, this will cancel, right? Oh, I apologize, I crossed off the wrong one. Let me correct that here. This one canceled, right? So I have to take 2 times 3x minus 1, so I get 6x minus 2. Now when I distribute here, the other one cancels, so 3x minus 1 cancels, so I take 3x plus 3h times 2. So that's going to be, and actually I should highlight it's negative 2, I'm going to multiply. So it's going to be negative 6x, and then negative 6h plus 2 all over h. And again, I am not going to distribute that through. You're going to, again, see that h is going to cancel off. A lot of things cancel here. So the 6x, the 2's, and I'll write this extra step in here with the canceling. So the limit as h goes to 0 of negative 6h, and then that h is going to cancel. So I get 3h minus 1, 3x minus 1, and again, these h's cancel. So now I'm to the point where I've simplified as far as I can go, and I'm going to now take the limit as h approaches 0 of negative 6 over 3x plus 3h minus 1 times 3x minus 1. So now I can apply this. So that's going to go away. So I will get that to be negative 6 over 3x minus 1, 3x minus 1. And if I really wanted to, I could go ahead and simplify that. Again, what did we just find? This is the derivative, negative 6 over the quantity 3x minus 1 squared. So again, what does this tell me? I can plug in any x value. It'll tell me the slope, the instantaneous slope at that point of the tangent line anywhere along this graph of 2 over the quantity 3x minus 1. Okay. All right. So this is your limit definition. Your homework is to finish this packet. Okay. And then upload that to Schoology.